I finally got Monday's lesson ready. Monday's lesson is an extension of Friday's lesson, still quadratics in what's called standard form. So let's go through here and do a couple of these. I'll do number one, save number two for y'all. So this is a transformation of x squared, and you're asked to determine what transformations happened. And the only way that you can do that is to either graph the function, which there's lots of ways of graphing functions, or converting into vertex form. So that's what we're going to do. We're going to convert into vertex form because that's what I'm trying to teach today. There's a couple ways of doing this. I was taught a brute force method, which I think maybe 1 in 10 people could probably do. I taught you guys to find the vertex. Your vertex is at negative b over 2a and then f of negative b over 2a. That's where she is. So remember, here's A, here's B, and here's C, because it's in standard form right now. So I can figure out the opposite B over 2A part. That's going to be at negative 12. I'll call that H, by the way, because it is. It's at negative 12 over twice of 6, which is negative 12 over 12, which is negative 1. And then what I have to do is I have to plug it back in, because it says f of negative b over 2a. So I'm going to take my negative 1, I'm going to plug it into the equation. F of negative 1 is 6 times a negative 1 all squared plus 12 negative 1s minus a 2. And some kids will really freak out at that. If you take a negative 1 and square it, you get 6. 12 times negative 1 is negative 12, and then minus 2. 6 minus 12 is negative 6. If you take away 2, you're sitting pretty at negative 8. So my vertex from the math I did is sitting at negative 1, negative 8. This value out here is still A. Your kind of slope is A, capital A here. Notice it's not a lowercase a because it's not vertex form, is 6. Anyways, vertex form is done now. I've got H, I've got K. So my equation here is going to be 6, because there's a 6, x minus a negative 1, that becomes plus 1, quantity squared minus 8. And there is my function. I should have called it h of x. I'll see if I can go back and rewrite it, because the transformation function is not going to be the same. Anyways, I got 3 transformations. Vertical shift down 8. Horizontal shift left 1. What did I just say? Left 1. And your scale factor is right here. Your kind of slope is right there. We have a scale factor. It's a vertical stretch. With a factor equal to 6. I guess I better get that message. My phone's gone off. What do we got here? Let's see, 3 and 4 are very similar problems. So I'll do number 3. Function f of x equals x to the second has the following transformations applied in a specific order. We are shifted up 4. Everybody and their mama knows you just add 4. We're shifting left 3. You want that to be subtraction, but according to the forms you've learned, it's actually addition. It happens on the interior. That does a left 3. Stretched by a factor of 3, that goes on the exterior. And then vertically reflected. Well, I just negate the 2 pieces I've written. There's technically only 2 things here because of multiplication. This is a quantity, and that's a quantity. and they're not alike. There you go. Part A was give the transformed equation, just did it. Part B is to convert that sucker into standard form. So in order to square something, what you have to do is you have to write it twice, because you have to multiply it by itself. So it looks like that. I write this quantity twice. And here I get to invoke the double distributive property. I'm going to leave this negative 3 here. X times x is x to the second, plus a 3x, plus a 3x, plus a 9, and then all minus 4. The double distributive property is such a big deal. Most people who write what we're supposed to teach, they assume, and I believe it's correct, that everybody should be able to do it. But when you get in a classroom, you're fighting that don't care. That's what you're fighting. So I don't care if you don't want to do it. I mean, I do, but I know that you can do it. It's not a matter of what you want, it's a matter of what you can, and you can do this. I get the don't want stuff. I completely understand apathy. I've been alive long enough to understand apathy. There are things that I do not much care doing. Wait till you have kids. You'll understand that. Love them, but man, I'm tired of changing butt. Distribute that negative 3. Negative 3x to the second minus 18x minus 27, and don't forget about the minus 4. Put it all together, and this will be our function, which I need to be calling h of x because it's not the original. The original was f of x. It's got to be called something else. Negative 3x to the second minus 18x, and I'm pretty sure if you put those two little numbers together, you get minus 31. If I'm wrong, let me know, because I'm not flawless, and I'm not going to double check myself. I ain't got that kind of time. If I do all your work, I'll miss lunch break. Not that I actually eat lunch, but whatever. 5 and 6 I'll leave for you. I will do number 6. It says graph the following by converting, if necessary, and it is necessary to do number 6, the given equations into vertex form and finding the x and y intercepts using algebra. Bro. I'm actually going to I wonder if I should have. You may not be able to find the x-intercepts, but or I may have to just teach you something you're not aware of right now. It's called the quadratic formula. We'll see. We'll see. Anyways, what do I want to do? I want to convert this into vertex form. H would be at opposite B over twice A. That's going to be negative 12 over negative 4, which is at 3. K is found by plugging that 3 in. Looks like an intimidating little number there, doesn't it? This is 9, that's negative 18, that's 36. 36 minus 18 is 18. Take away 22, it's negative 4. And how do I find x and y intercepts? The y intercept's easy. I'm going to do it first. Y intercept, we let x be 0. 0, 0. That is always the y intercept in standard form. Anyways, we let x be 0. The y-intercept is negative 22. Technically, it's 0, negative 22. Boy, that's going to be a hard one to graph, isn't it? You're going to have to break the scale. X-intercepts. I might should have thought about this problem before I assigned it, because I'm not sure if it factors. So let me pause the video real quick. Not a big deal if we have to do something else. You need to learn it anyways. So it actually doesn't have any x-intercepts, and this is how I know. I'm just going to do the work here. X-intercept, we let y equal 0. I'm going to sing you a little song. It goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. It's called the quadratic formula. By the way, it shouldn't. this thing crosses the y-axis at negative 22 and opens down. You're probably listening to this muted, have no idea what I'm saying. It opens down, crosses the y-axis at negative 22. It doesn't have a y-intercept, or an x-intercept, most likely. Most likely. All right, so there's A, there's B, there's C, and actually one thing I can do is I can make the numbers smaller. I can pull a 2, a negative 2 at that, and then A is 1, B is negative 6, and C is 11. So opposite B would be positive 6 plus or minus square root of 6 squared minus 4 times A, which is that 1, times C, which is that 11, all sitting over twice A. And what I get here is I get that x is 6 plus or minus 36 minus 44, the root of negative 8 over 2. These are non-real answers. You can't take the square root of a negative and be real. It's technically imaginary. So I don't have any x-intercepts. I just have a y-intercept. What else needs to be done here? I am supposed to convert this into vertex form, which I have. I have h and k. So vertex form. Here's my a value. Y equals negative 2 times x minus 3, quantity squared minus 4. And now I can graph it. Since I know some stuff about this, like not having x-intercepts, I'm just going to draw quadrants 3 and 4. Hopefully you are not amongst the group of kids who was taught the quadrants wrong. There was 2 classes in a row that were taught quadrants wrong. They were taught 1, 2, 3, 4. Ouch. People we pay to teach math. Anyways, I got to go right 3, 1, 2, 3, down 4. That'll put me right there. And my initial slope is to fall 2 and run 1. And then I got to go down to 22 to get the y-intercept. What am I at now? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Be about right there. And the reason we find intercepts is because we know more about the graph. There you go. That's 6. Have fun with 7. 7 most likely does not have x-intercepts. I might redo that equation, circle that, and remind myself to redo 7 so that it's something you can do. I'll make up something that factors. Let's see, we got some ACT practice. It says, yeah, you got to do it, you got to show your work. So last month, Lucy had total expenditures of $900. Good Lord, I probably spend $900 to $1,000 a week on my family. This must be an old test. The pie chart below breaks down these expenditures by category. The category in which Lucy's expenditures were greatest is what percent of her total expenditures? To the nearest 1%. So we want to know what? Greatest. And Lucy looks like the typical female. She spends most of her money on clothes. Nice. So she spends $254 out of $900 on clothes. And we're supposed to convert that to a percentage. Say your calculator messes up on the ACT. What you gonna do? You're gonna do some long division, right? Wouldn't kill you. 900, 254, 254 going to 900, what, 3 times? Right? So I've already just narrowed it down to that and that. 3 times 254 is going to be 762? I think that's right. Seems reasonable. Going to do a little subtraction. Going to get 138. Going to have to kind of carry the decimal there or whatever. I did that backwards, didn't I? Way to go, math teacher. It's 900 and 254. 900 does not enter 254, so you got to include the 0. I hope you caught me on that. I hadn't done long division in a while. This will go 2 times. I threw away a wrong answer because I screwed up. It's going to be one of these two, isn't it? It's probably 24%. They don't actually expect you to do this. They expect you to say, oh, it's got to be less than 25% because 900 is less than 1,000. But anyways, long division. Do the subtraction, we get 740. And 900 won't enter 740, so you introduce a decimal. And it seems like 8 times 9 is 72, so there you go. There's your 28%. Aha. It is 28%. I just said some words wrong. It's B. I completely murdered that thing, didn't I? Took a knife out and stabbed it 40 times. In the figure shown below, the measure of angle BAC is x plus 20 degrees. I'm going to put that on my little thing. B to A to C is x plus 20 degrees. The measure of angle BAD is a 90-degree angle. What is the measure of angle CAD? They want this guy. And we don't have a clue what it is. Do they tell us anything else? They want CAD without making an assumption. Well, here's what I know about angle CAD. It is 90 degrees minus all of x plus 20. Not just part of it, all of it. So 90 minus 20 is 70 minus x. And they have some good distractors in there, assuming, well, they're kind of probably hoping a kid doesn't do something. These down here are references to the kids who like to add up to 180 degrees, but it's choice G, straight out geometry. In the perimeter, what is the perimeter in inches of the isosceles right triangle whose hypotenuse is 8 root 2 long? So when you had Miss Cantrell last year, she asked you to memorize x root 2, 45, 45, 90. You memorize it. Mr. Milbrath, how can I get a good math score on the ACT? Rote memorization. Crap loads of it. Anyways, to go from the hypotenuse to a short leg, you divide out the root 2. And there you go. She is 16, 8 plus 8, plus 8 root 2. Choice E. There's a longer way to get that answer using Pythagorean theorem. What is the product of the complex numbers negative 3i plus 4 and 3i plus 4? And complex numbers are real plus imaginary. This actually got pulled from your Algebra 2 standards, but I'm going to teach it anyways this year because it's on the ACT. And my job is to give you opportunity. We're going to FOIL. Negative 3i plus 4 times 3i plus 4. These happen to be conjugates of each other, which is nice. All right, so we do the double distributive property. Negative 3i times a positive 3i is negative 9i squared. Here we'd have minus 12i plus 12i plus 16. Now, it turns out that I is the square root of a negative 1, which, if you square both sides, tells you that I squared is negative 1. So that becomes a negative 1. Those two cancel each other out. And I end up with 9 plus 16, which is 25. I knew that a few minutes ago because I said they were conjugates of each other. The radius of the base of the right circular cone shown below is 5 inches, and the height of the cone is 7 inches. Solving which of the following equations gives a measure theta of the angle formed by the slant height of the cone and the radius? I don't think you need to do any math here. I think you just need to remember SOHCAHTOA. I don't know if you remember it or not, but you had your little acronym, SOHCAHTOA. There's usually 5 questions on the ACT deal with some sort of trigonometry. Well, if you're at theta, 5 would be adjacent to it and 7 would be opposite. I'm that dude right there. The tangent of theta is 7/5. That's the one I wanted. That's how hard it is. And the last one, and I can go have a lunch break, which is mainly me sitting around with other teachers and we talk crap about all of y'all. Just kidding. We don't give you any time during lunch. To make a 750-piece jigsaw puzzle more challenging, a puzzle company includes 5 extra pieces in the box along with the 750 pieces. Man, that's wrong. If those 5 extra pieces do not fit anywhere in the puzzle, and if you buy such a puzzle, break the seal on the box, and immediately select one piece at random. What is the probability that it will be one of the 5 extra pieces? Well, that's not too hard. It should be 5 and 755, shouldn't it? There's 5 pieces. There's 755. Huh. They didn't even do anything weird like reduce the fraction. There we go. There's Monday's homework. Hope you enjoyed it.